Hello. So this is all about topic 1.6, which is about compound inequalities. So we'll start with exploring reason, and that is on page 43 of your workbook. All right. So we're on page 43. All right. So let's get started. So the explore reason section. Hannah has some blue paint. She wants to lighten the shade, so she mixes in 1 cup of white paint. The color is still too dark, so Hannah keeps mixing in 1 cup of white paint at a time. After adding 4 cups, she decides the color is too light. Okay, so what we've learned is that 1 cup is too dark, and 4 cups is too light. Okay. Part A says, explain in words how much paint Hannah should add or should have added initially to get the shade she wants. So if 1 cup is too dark and 4 cups is too light, then she's going to need between 1 and 4 cups. Okay, so that's where we've gotten. So we actually just put that on our paper. So since 1 cup is too dark and 4 cups is too light, then Hannah should add between 1 and 4 cups of white paint. To get her desired shade. Okay, so there's that. Part B says, represent your answer to part A with 1 or more inequalities. So again, the 1 cup was too light, the 1 cup was too dark, and the 4 cups was too light. So she needs more than 1 cup, and let me actually write that, and she needs, and I'll just put it here, and she needs less than 4 cups. And if that's the case, this is what we can say. We've got 2 inequalities. So if she needs more than 1 cup, we'll just have, since we're talking about white paint, W is going to be our white paint, or cups of white paint. All right, so we'll have W needs to be more than 1, so greater than 1, and W also needs to be less than 4. Okay, so the cups of white paint needs to be between 1 and 4, so bigger than 1 but less than 4. Part C, Hannah decides that she likes the shades of blue that appear in between adding 1 and 4 cups of white paint. How can you represent the number of cups of white paint that yield the shades Hannah prefers? So what they want us to do here is, all they want us to do is they want us to combine these 2 inequalities that we wrote in part B. All right, so we need to combine them to show that both of them are true for Hannah. That's what we're going to do to get her perfect shade, or at least a bunch of perfect shades, right? So what we have is that Hannah's desired shade lies between 1 and 4. Okay, so we know to get her desired shade, she's adding in these cups of white paint. And remember, up here, we said that white paint is W. Yes, that's how she's getting her desired paint, or desired shade. So we're going to have W being between 1 and 4. Okay. All right, and of course, this reads that the desired shade is between, so the desired shade for shades lies between 1 and 4 cups of white paint. Okay? All right, and then habits of the mind. If the solution to an inequality includes all of the values that are in between two values, how can you show that on a number line? So if we're saying, they're just asking us how to graph it, right? So if we're saying that the desired shades lie between 1 and 4, let's just go ahead and graph that on a number line. If I'm doing that and I have a number line, we're going to have our two values, our two outside values, right? We have 1 and 4, and we know we've got 2 and 3 in there, right? So if it's between 1 and 4, well, 1, we can go back to what we already know about graphing inequalities. And we know, oops, not that. We know that if we have less than, basically for both of them, or greater than and less than for the W, or you can even just go back and do this. You know, if it's going to be between 1 and 4, then these two symbols are not, that means that these numbers are not included. In the solution, based on what we learned in our previous lesson. So I know that they're going to be open circles at 1 and 4. And if the W, or our solution, is between 1 and 4, then I'm going to have this middle section shaded. Okay? So that's what I am going to do. I'm just going to use a different color to make it super obvious that that's what I'm doing. Okay? So that's where the solutions lie. Okay, so she's either going to have probably 2 to 3 cups, right? So that's probably where she's going to be. All right, so there is our model and discuss. Okay, so moving on to our examples. So the first one says to write a compound inequality for the graph. All right, so for this graph, again, what I like about these is it makes it super easy for me to write these out because I know I'm looking at the outside numbers. So put this on your paper, that for notes, write the two outside numbers on the outside of the compound inequality. Okay, so I've got -2 and 6, right? And I know I'm going to have an X in between because I've got something that's in between. The reason I know that I'm going to have, again, this is going to be for an and statement, meaning I've got two different things, right? And they're combined together. I know that they're like kind of stuck together so they have some kind of commonality because they overlap, right? So put that on your paper that we have a section of overlap, an overlapping section. When you have an overlapping section, then you have an and compound inequality. So they just share a piece. Okay, then I'm just going to go by what my symbols are telling me. So if I have an open circle and it's shaded to the right, then I must have a greater, then I must have, for X anyway, X is going to be greater than that -2, right? So if X is greater than -2, then what I'm going to say is I'm going to have my symbol open up to X. All right, then I look at my other symbol here, and I have this closed circle. So if I have a closed circle, I'm going to have the or equal to part of my inequality. And my X is whatever's overlapping, right? So X is going to be anything less than the 6, right? So if it's going to be less than, the pointed part of the arrow needs to be pointing to the smaller number, which is x. So this is what I actually have. And if you, well, hopefully while we're reviewing this and going over this together, you'll learn that if you're writing it this way, the inequality symbol should always kind of look similar to that, where you have either a lone variable or you have an expression somewhere in the middle, but your variable is always going to be on the inside of two of those inequality symbols, and they'll be pointing like this. Okay? All right, so moving on. And that was our answer there. So, yeah. All right, moving on. Number 2 says solving it with an or. So this is what I was talking about with and was up here. Oopsie. And was up here, and or is down here. All right, so with an or statement, instead of them coming together and overlapping, they will never touch, okay? So with an or inequality or compound inequality, what's going to happen is I'll have two inequalities, and they'll be shaded in different directions. Okay, so as you notice here, we've got our two inequalities there, and we're going to solve both of them in order to figure out what our what numbers we'll be focusing on. Okay, so let me just rewrite. So I've got this here on my page, and then here. All right. Okay, so let's go ahead and answer that. So what I'm going to do is I'm going to subtract 2 from both sides from this left inequality, and I'll go ahead and solve. And that'll be -9. Then I'll divide both sides by my coefficient, which is -3. When I divide by a negative, I'm using those same rules that we had for regular inequalities. I have to flip my symbol since I divided by a negative number. So x is now going to be less than +3. Okay? And don't forget I have my or statement, so when I graph, I'll have two inequalities graphed on the same line. All right? And let's put that on there. They'll need to be graphed on the same line. Okay, and the other, what I'll go ahead and do is I'll just distribute. So I'll have 2x minus 4 is greater than or equal to 6. I will add 4 to both sides. Drop down. So I'll have 2x is greater than or equal to 10. Divide both sides by my coefficient. X is going to be greater than or equal to 5. And again, I can look here and see that I've met the qualifications of an or compound inequality, where I have two inequalities, obviously, 1 and 2, and they're shaded in, I'll be shaded in different directions, where one of them says x is less than a number, and the other says x is greater than a number. So one will be shaded left, and one will be shaded right. Okay, so I'm off to a good start. Okay, so I'm gonna go ahead and move on from here. So now that I have this, I'm gonna go ahead and graph this on a number line. So I'm gonna draw a number line, and I know I'm gonna need these two values on that number line. I'm gonna need my 3, so I'm just gonna go normally on a number line. Okay, well, good enough. Okay, so with this in mind, at 3, again, I'm gonna just put on the side of my paper here what these symbols mean. When I have less than, this means that I'm gonna have an open circle, shaded left, and when I have greater than or equal to, I should have a closed circle, shaded right. Okay, again, because any values that are to the right of 5 are going to be greater than that, and any values to the left of 3 are going to be less than that. All right, and I'm going to just extend my line here so I can easily see that. All right, so at 3 again, I'm going to have an open circle, and I'm going to shade to the left because that was less than. And make sure you make your line extremely thick so it's super obvious to anybody who's looking at your paper. Me, okay, or your other teacher. All right, if anybody's looking at your paper, they should know exactly what you meant. All right, and the other way, I should have my 5, and I should have a closed circle. And it's going to be any value greater than 5. And I can see to the right of 5, I have 6, which is bigger than 5, so I should shade to the right side. Okay, so go ahead and fill that in on your paper, and you're done with this problem. Okay, so there is that example. Habits of the mind. So these habits of the mind, all they do is just they kind of summarize what we just learned. Okay, so it's nothing too bad, just going over what we've done and generalizing these, concepts. All right, so how does representing a compound inequality solution on a graph help show the solution accurately? So it's giving you a visual representation of where your solution actually lies. Okay, so that's what we want. That's why you graph things, so you can see it visually. Just a really good representation. So it's a good visual representation of where your solutions lie. Okay, so then what you could do is it makes it super easy to check different values, right? Makes it very easy to check. To check different values. To see if they're parts of solution, to see if they are a part of the solution. Okay. All right. So for example, like if I asked for like 3.5, if I asked you to test 3.5, so is 3.5 part of the solution? Well, I could locate 3.5 on my number line and say, well, it's not in either one of my shaded areas or on this closed circle. So no, it's not part of the solution. So it's a good way to make sure, like whenever I've graphed it like this, it's a good way to just test certain values to see if they actually are part of that solution. Because if I'm just looking, I can make a mistake, right? But if it's graphed, I could literally graph them on the number line and see if they lie on one of these shaded areas. Okay, so that's why we graph it, basically. All right, moving on. Number 3, solve the inequality. Solve the inequality or the compound inequality and graph the solution. Okay, so same type of deal. So if I have this and statement, again, I'm just going to solve it like normal and just kind of, put them together at the end. Okay, so remember, for an and statement, you're going to make it into one big statement. So an and statement, we've got an overlap of the shaded regions. Okay, an or statement, there would obviously be no overlap. Different directions. Okay, so let's go ahead and solve, and I'll rewrite first. All right, so the first thing I do is go ahead and distribute my -2. So I have -2x minus 2 is less than 4. I would then add 2 to both sides to move my constants over to the right side. and drop down my variable term. So I have negative 2x is less than 6. I have to divide both sides by my coefficient, which is negative 2. Since I'm dividing by a negative, I have to flip my symbol. Okay? So I've got to do that. I don't know why I did that. So when you divide by a negative, then flip your symbol. Okay? So what I'm going to have is instead of saying x is less than, I'm not going to have x is greater than negative 3. All right, moving on to the other side. I'll subtract 1 from both sides, so I have 4x, because I dropped that down, is less than negative 4, and I'll divide by 4. So here is a good example of when you're not going to flip. So just because this other side was negative doesn't mean I'm going to flip my symbol. I only flip my symbol when I divide by a negative. So I'm really dividing both sides by this positive 4. So I'm going to leave it alone even though my solution is going to end up having a negative number on the right. Okay, and that's okay. All right, so I'll have x is less than or equal to negative 1. Okay? All right, so with that in mind, I'm going to go ahead and graph it so you can even see that they overlap. So I need to have at least negative 3 to negative 1. So I'm just going to start with negative 5. Never make them long enough. It's okay. That's why we have erasers. Okay. So at negative, if I'm going to go ahead, I'm just going to graph them normally. And wherever they overlap, I'll draw or I'll use a different color so you can see what it looks like. So if we have x is greater than negative 3, we need, looking at this symbol, we have greater than, which means we're going to have an open circle, because if x is greater than negative 3 is not greater than negative 3. It's not greater than itself. So it can't be included in my solution. So I'm going to have an open circle at negative 3. And if it's greater than negative 3, it's going to go this direction. Okay, so I'll have that there. And I'm going to use a different color now for the other way. All right, the other one, I have a negative 1. So at negative 1, I need to have, I'm looking at this symbol, okay? So even if I didn't remember it, if I have less than or equal to, if I plug in a negative 1 here for x, so if I say negative 1 instead of just x, is negative 1 less than or equal to negative 1? Yes, it is. It's equal to it. So negative 1 is actually included in the solution. So I'm going to have an open or closed circle here because it is included in the solution. So closed circle there. But this time, x is going to be less than or equal to negative 1. So I need to shade to the left side. Okay? So when I do that, I'm going to see I have an overlapping section, right? I have this section here that is now overlapped, right? So it has both this really dark purple and that light blue. So since I have these two sections, that's actually where my solution lies, okay? So my solution is between those two numbers, negative 3 and negative 1. These are where my solutions are for x, okay? The overlapping section. Okay, this is what I've been talking about, where I'm saying that for the and you have these overlapping shaded regions. This is my solution here. Okay, and I'm going to identify that right here. So the pink is where my solutions are. Okay, those overlapping sections. It's a good question. All right, example 4 says, suppose River has nutrients that are 10 calories each. How many of the nutrients can she have and remain in her calorie range? All right, so here's some background information that you actually need in order to solve this problem. All right, so one of them is that River's calorie range is between 510 and 540 calories per day. Another thing you need to know is the treats that she actually has. So the treats. The first treat comes in at 320 calories per serving. And she's having 1.5 servings of that. And finally, the other treat, so 2 treats, which we know up here, is 10 calories per treat. That's all you needed to know there. All right. So now that we have this information, we can go ahead and solve this problem. So the first thing that I'm noticing here is we have this range, right? Again, this is her calorie range. So her calorie range needs to be between her upper and her lower, right? So she can't have too much and she can't have too little. So we know the smallest amount that River can have is 510, and the largest amount is 540. So it seems like she can have exactly that amount. So if she can have exactly 510, we're going to put the 510 here, and I'm going to use a different color to not get confused. All right, so we're going to have the 510 here and the 540 here. And we're going to assume that she can have exactly 510 and she can have exactly 540 as well. So it should be included. Now in the middle, we should have her calorie range. Or actually not the calorie range, this is the calorie range. So just her calories should be in the middle. All right, so where are these calories coming from? Well, they're coming from the treats that she had. Okay, so if you recall, she had 2 treats. So we should have 2 things in the middle. So one of them is the amount of calories that she had from this first treat, which was like really high here. So she had 320 calories per serving, and she's getting 1.5 servings of that. So we need to do some quick math here. We need to do 320 times 1.5. Okay, to figure out what's coming from this first treat. And I'll put this here. So treat 1 versus treat 2. Okay, that's what we're adding together. Okay, when we solve, we've got this. So you're probably going to be a little bit faster than me with this multiplying if you have your calculator or something. All right, and I've got 480 here. Okay. So I know that with treat 1, she's getting 480 calories. And, yep. Okay. So she's getting 480 calories from treat 1. And from treat 2, we're literally trying to figure out how many of treat 2, like how many numbers of treat 2 she can eat, right? To stay within her range. So it's going to be, we know it's 10 calories per treat. So let's just say 10x, where x is going to be our number of treat 2. Okay, it's how many treats she can actually have from the second type. Okay, and the last thing we have to do is just go ahead and solve. And solving is actually really easy here. So I'm going to just erase this part here because that's where we just kind of, we don't really need that anymore. And we're going to solve like normal here. So if I was just solving this, what I would do is I would go ahead and move the constants where they go. So this constant needs to move to both here, but I got to keep it balanced. So if I moved it to the left, I got to move it to the right as well. Okay, so I'm going to go ahead and subtract off 480 from both because we know for a fact she's going to have that one large or that one treat that's like a lot of calories, right? She's going to have that, and then she'll have the 10x remaining. All right, when I do my subtracting, over here on the left, I have 30, and on the right, I have 60. All right, so remember, this 10x represents that one other treat, treat number 2. That's 10 calories per treat. We want to see how many treats she can have. So they're all this is her range now. She's got between 30 and 60 left. So our final stage, or final part, is to divide both sides by 10, or actually divide all parts by 10. Okay? So we're going to divide every single part by 10, and that's going to tell us what range she can have. All right? So when we do that, we've got this gone. The zeros are gone. So I've got 3 is less than or equal to x is less than or equal to 6. So this means that River can have between 3 and 6 10 calorie treats. Let's just call it that. 10 calorie treats. Okay? And that way she'll stay within her range, her calorie range. All right, so this was really good, okay? I really like this problem. It was a really good real world problem. All right, and we have that final one here. Let me get this out of the way. Okay. All right, describe the solution of an inequality involving or and an inequality involving and. So we know the solution for or versus and is going to have the overlapping section when you're graphing, okay? So wherever they're overlapping, that's where you can find your solutions. The or solutions can be in any of the shaded region, okay? So any part in the shaded regions. And of course, you'll have 2 of those shaded regions, okay? So for or, it's going to look like this, where I've got like this going this way, and another going the opposite way, right? And is where they're kind of married, right? So I've got this and this, but the solution is going to be in between, okay? All right, so there's that. And our final part of our notes today is going to be the do you understand part. I normally try to leave this for you guys, but I'm not there, so I want to make sure that you've got the new concept today. All right, so do you understand? What are compound inequalities and how are their solutions represented? Okay, compound inequalities are when you have 2 things that you're comparing together, and sometimes they overlap and sometimes they go in different directions, but anyway, you're going to find them in the shaded region, okay? So solutions are graphed and found in the shaded regions. Okay, compound inequalities, we have 2 types. We have and compound inequalities, and we have the or compound inequalities. For or, I have 2 inequalities going in different directions. And the and, I have 1 big inequality, or I could have 2 overlapping inequalities. So 2 inequalities that overlap, right? So overlapping sections. Okay. All right, number 2. When A is less than B, how is the graph of A is greater than A, or I'm sorry, X is greater than A and X is less than B, similar to the graph of X is greater than A? And how is it different? Okay, so let's look at that. So if I've got an A and I've got a B, how is the graph of x is greater than A? So let's graph that. X is greater than A will be an open circle, graph to the right, or shaded to the right. And x is less than B, so the other way. Open circle that's shaded to the left. So those overlapping sections, that's where I'm going to find my solution. So it's going to be between these two areas. Okay? So the pink section is my actual solution. That's an and statement, or an and compound inequality. All right, how is it similar to the graph of x is greater than A? So again, they have that overlapping part. That's what they really want to know. Okay, so it's going to be between going to be between A and B. So x is really going to be between A and B. That's all they really wanted to know. And it's those overlapping sections in the middle. Okay, vocab. A compound is defined as a mixture. Make a conjecture as to why the term compound inequality includes the word compound. All right, so, well, hopefully you'll be able to do this one on your own, but just to make sure that you understand the concept, a compound inequality is a mixture of two different inequalities. They're literally either pushed together, they're combined some kind of way, right? They're literally mixed onto the same number line. Okay, so if compound means mixture, then a compound inequality is a mixture of two inequalities. Okay, they're going to be graphed on the same number line. Okay. Number 3 says error analysis. Kona graphed the compound inequality x is greater than 2 or x is greater than 3 by graphing x is greater than 3. Explain Kona's error. Well, okay. If we try to graph what Kona just said, Kona said we've got 2, we've got 3, right? Kona's saying this. He's saying x is greater than 2. And then we've got x is greater than 3. The only one that would be true for this is the x is greater than 3, right? That's the only way this could be true. The reason I say that is because the only place that I see an overlap is here. This is where the true solutions are, right? Where x is greater than 3, right? So the solutions here are only x is greater than 3. But that's not what he was trying to do, right? So if he graphed that inequality, and if it's supposed to be an or, the or statements are supposed to go in different directions. Okay, if it's an or compound inequality, so these or compound inequalities should go in different directions. Because what's happened here is if he was trying to say that these were two, these two inequalities were similar, or like they had a comparison or something because of the or part, right? There's no way that they should be an or statement at all. Maybe it's supposed to be an and somewhere. Maybe the x is greater than 3 should have been x is less than 3. I don't know. But what's happened is if the solutions are only at x is greater than 3, because that's where they overlap here, we're left off with the x is greater than 2 part, right? So we have this gap in between 2 and 3 that is not part of the solution at all. And there's no way that it can be a compound inequality when I have this gap here, okay? It can't be both ways. It can't be both an or statement and an and statement, right? If it's an or, then I shouldn't have an overlap, right? With or statements, there is no overlap at all. So he's like combined an or statement and an and statement, and that's just not possible, okay? So he's just combined the qualities of both of them, and that's just impossible. All right, moving on to number 5. It says to write a compound inequality for each graph, and these are really easy right here. So graphing them, all you got to do is look at where the points are, look at where the dots are. Right, we got a dot at 4, or I'm sorry, a -4 and a -1. Put the smaller one on the left, so smaller number, and whatever the inequality symbol is, got x in the middle, and the larger number should be on the other side. Okay, so my smaller number is -4, x in the middle, right? I'm just gonna put that there, and my larger number is -1. So next, before I only did that because, you know, I just wanted to make sure you knew they were going that direction, but I got to make sure that I did it correctly. I have 2 closed circles here, so I should have less than or equal to for both these symbols. All right, so let's make it less than or equal to, and the reason I did that is because I have a closed circle here, and I have a closed circle here. Okay, so there's that answer there. This next one, oh, I did this wrong. Whoopsie. Okay, these are 2 literally going in 2 different ways. I didn't even pay attention to that. Since they're going in different ways, I actually have an or statement where I'm comparing x to 2 different numbers. So this is only going to be when you have an and statement. Or statements are just normal. All right, so or x is going to be less than -4, or x is going to be greater than or equal to, -1. Okay, and sorry about that mistake. So I've got my number here, and wherever it's shaded is where my solutions are. So that's how you talk about x. Okay, since it's going to the right, it must be greater than. And if you notice, since I put my x on the left side, my symbol tells me which direction that my line was going in. So I know that way I've done it right. Same thing over here, pointing to the left. My line's pointing to the left. Okay, now I have an and statement for number 6. And I know it's an and because they're kind of together, right? When they're together like that, meaning they share, a common piece, then that's going to be an and statement. So I've got one long one like this where I have the 2 symbols. Okay, so I've got my 2 symbols, put the small number on the side, the larger number on the other side, x goes in the middle, and see if you have to change it. You only have to change it like the symbol if you have a closed circle. So here at 2, I have a closed circle, so change it. Make it less than or equal to, the one that touches the 2. All right, and you're done there. All right. Number 7 says solve each compound inequality and graph the solution. Cool. If it's an and, I know for a fact it's going to look something like this, where I have those 2 things, right? Something in the middle. That's what I want. All right, and if it's an or, they should be going in different directions. One goes left, one goes right. Okay, just so I know that's what it's supposed to look like. So it gives me a visual reminder of what it's supposed to look like, so I don't forget, like I did earlier. All right, so we just have 2 inequalities to solve. So let's add 1 to both sides here and simplify. So I have 4x is greater than 4. Divide everything by 4. X is greater than 1. Got that. And we have, I'm just going to go ahead and divide both sides by -2. Since I'm dividing both sides by -2, I'm going to flip my symbol since I divided by a negative number. And I've got a positive 8 there. I'll add 4 to both sides. I'm going to have 3x is less than or equal to 12 and divide by 3. So x is less than or equal to 4. Okay, so this is my actual compound inequality here, where I've got x's in between 4 and 1, where 1 doesn't have the inequality symbol, the equal sign, but 4 does. All right, and I'm going to use a black here. So I have a 1, I have a 4, open circle at 1, close circle at 4, and I'm going to shade in between because it was and. There we go. All right, there is that one. All right, number 8. We still have 2 different ones, so let's go ahead and solve. Okay. All right, so I'm going to go ahead and divide both sides by 2. So I'm going to have 4x plus 3 is greater than or equal to negative 5 minus 3 on both sides. 4x is greater than or equal to negative 8 and divide by 4. So I get x is greater than or equal to negative 2. Moving on, I'll add 15 to both sides. Negative 5x is greater than 20 and divide by negative 5. I've divided by negative 5. I've got to flip my symbol. X is going to be less than negative 4. Okay, and these were or statements, so I can go ahead and graph. I've got a negative 4, and I've got a negative 2. I'm going to make them in different colors so you can see. So the negative 4 should be an open circle, and if x is less than negative 4, so shade it to the left. And finally, the negative 2 is a closed circle, and x is greater than that, so it should be shaded to the right. Okay, there is that one. And finally, we have number 9 here, and that'll be the end of our notes for today. All right, Nadim plans to ride her bike between 12 miles and at most 15. Okay, write and solve an inequality to model how many hours Nadim will be riding. Okay. All right, so here in the picture, they tell us that she's going 10 miles per hour. It's probably going to be 10h. All right. Okay. Okay. So we'll have between 12 and 15. And they said at most that much, right? Then we've just got the 10h here, right? Because it's 10h is my h is hours. Right, and if I want to know between how many hours she's going to be doing this, all I'm going to do is just divide everything by 10 to get that h alone in the middle. Okay, so I've got 1.2 here is less than or equal to h is less than or equal to 1.5. Okay, so that should tell me how many hours she's going to be riding. So Nadim is going to be riding between 1.2 and 1.5 miles. Between 1.2 and 1.5 hours. Okay, that's what she's going to be doing. Okay. And I'll put that in words. Nadim will be riding between 1.2 and 1.5 hours on her bike. All right, and there we go. All right, so you are now needing to work with a partner, hopefully. On the practice problems that are assigned to you, you do have an online assignment that goes along with this after you get your practice problems checked over. And that'll be all. All right. Thank you.